Hello and welcome to Physicsify once again. We are talking about vectors. We are having this continuation where we are talking about vector addition in this particular session. This is part 7 that we are going to take up, and let's see what exactly are the things that unfold today. First of all, if I talk about the session outflow, like I said, I would be talking about the graphical method of vector addition. There's one more thing that we can see. Maybe we'll talk about that in a little while. But this graphical method of vector addition comes in three ways. So it could be either the triangle law of addition, it could be the parallelogram law of addition, or it could be the polygon law of addition. So how exactly are these three things? We'd mostly be talking about triangle law in today's session. So let us try to take that a little further. Now, what exactly do we have? First of all, we are revising something because this is going to be a little much related to what we have already done. So I hope everybody remembers we are talking about scalars and vectors. So if I want to talk about the addition aspect of both the things, I think I can say this very easily that with respect to scalar addition, if I was adding two certain things, then your simple algebraic functions 3 kg apples plus 4 kg apples will always give you 7 kg apples. You already know this. But with respect to the vector addition, two things can be added in a lot of different ways. If you want to add 4 meter and 3 meter in the same direction, I hope you remember that 4 meter plus 3 meter will give you 7 meter. Alright. How exactly? I hope you remember this part. That if this is 4 meter, let us say this is 3 meter, we get this one, green one, as 7 meter. Right. Similarly, if I talk about the next case, that 4 meter and 3 meter are in the opposite direction. So if I want to again add this 4 meter and 3 meter, but such that these are in opposite direction, I hope you remember we get 1 meter. How? I hope you did this earlier, no? 4 meter towards the right and 3 meter towards the left. Net addition, net resultant would be 1 meter towards the right, as you can see over here. And similarly, if I want to add this 4 and 3 meter in perpendicular direction, so I can also get this 4 and 3 as 5. How exactly? If I actually add these two vectors, 4 meter and 3 meter, such that these are in perpendicular direction, this used to give 5 meter. And you will say, we have already done all these things. How is this relevant to this session? So let me try to bring you the new things, that methods of vector addition. Like I said, we can talk about three particular methods in just the graphical method of vector addition. Alright. So what are the other different ways? First is graphical. We also call it geometrical method, where we are making use of diagrams. We are drawing things. And other one happens to be analytical method, which probably uses more of formula. It's more of mathematics rather than just drawing things up. And if I would just bring out both these things for you, I hope you would be able to understand it very clearly that this graphical or geometrical method is related to drawing or diagram. And similarly, your analytical method is related more to formula. Now, if we go try to delve a little deeper and try to explore about these graphical methods, what do we have? We talk about three different things. Like I was saying at the start of the session, that three particular methods could be seen. So if I want to get a triangle law, I would probably say that there is a triangle involved, right? If similarly I talk about the parallelogram law, I hope everybody knows how a parallelogram looks like, something like this. And there could be another method which is used whenever we want to add more than two vectors, and that is called the polygon law. Now this is very interesting. This again is something that comes in a little later, but you can say that if there are a lot of vectors, you can draw any type of a polygon, any type, right? And you can get the final result. You can add the vectors using graphical method in polygon law when you have more than two, right? Generally with respect to two vectors, triangle and parallelogram law is taken, but once it is a lot of vectors coming in, you'll generally tend to go towards polygon method. Again, something which we'll discuss maybe some time later, but for now we are talking about the triangle law of vector addition. Now what exactly lies here? I will say that if, let us say, there are two vectors given to you. I hope everybody can see that there is this grayish vector, there is this maroonish vector. Let us say we call these vectors A and B. So what exactly does triangular tell us? It tells us that if two vectors are represented. Now why have I underlined only this part? Because right now I just can see these two vectors. Right? There is a part of definition or the part of law that comes in later. Let's try to talk about that in the next slide. Right now we are just considering that there are two vectors represented. We're calling them vector A, we're calling them vector B. So if we talk about it in the next part, the next sense, the next part of the law, it says that if you keep those as sides of triangle, where I think A and B are the same vectors that we took, but if we see the statement itself, now we are adding this part that these are represented by two sides of a triangle. I hope everybody can see that this is a triangle and these are two sides, right? How are these two sides to be kept? They are to be kept in magnitude and direction taken in same order. That means once I have put in A, at the end of A, I have to put B. So that I take it in the same order. First A, then B. If there is a C, I will keep C at the end of B. But again, triangle law is generally with respect to two vectors. So that was the initial part already said, that if two vectors are represented. So if we represent them by two sides of a triangle as shown over here, taken in the same order with respect to the magnitude as well as the direction, then the next part comes. The next part comes in the next slide, and that says that this third side, I hope you can see this is the third side of the triangle that we drew out. It was dotted in the previous slide, but now it is a full line. So what we say over here is that then this resultant, what is the resultant? This is the resultant R vector. This is made by joining the common head and common tail. Now this, if I talk about, let us say I take these two vectors A and B. This is the common tail and this is the common head. At the end of these two, if I sort of want to draw this like this, so I will say this is the common tail, this is the common head. So this becomes your vector R, that is the resultant. And I hope this triangle law is now more than clear to you. Right. So let's probably have an example to make sure that we have learned this concept a little further and hopefully gotten it fixed into our minds. So what exactly is the example given to you? You're given a vector A. You're also given a vector B such that this angle, let us say, is theta. Now, you probably want to add these two vectors. Let us say we are asked specifically to add using triangle law of vector addition. So what will I do? I will put A. If you see, at the end of A, I have put B. A vector I have taken directly. B I have slided over here such that this angle is theta. So finally I can say that this is the third side, the R vector that you see. This is the resultant vector and you can say that this is the third side of the triangle. And if I draw this angle as alpha, the next things that I can say is, first of all, that vector A plus vector B equal to vector R. Please remember these arrows at the top are very important because these only signify that A and B are vector. Otherwise they are just numbers and then whole things that we have studied till now in vectors goes for a toss. Right. Next thing we can say that magnitude is the length of the third side. Whose magnitude? This is the magnitude of vector R. That length of the third side, that is this much length, is going to be the magnitude. And if I talk about the direction, I've already defined alpha for you here. You can say this alpha is with respect to A. WRT means that this is with respect to vector A. So I hope you understood that example. Let's do one more question before we finish this section off. So the question says that there is a girl who's moving 3 meters towards the east, that is towards the right. Then she takes a 90-degree left turn and moves 4 meters towards north. You have to find the displacement of the girl. Now for all those who don't know what displacement is, I would just like to say displacement means final position minus initial position. You want to know where exactly the girl was initially and where she was finally. Right. Now one good thing is that we are given some options as well. We're given A part 7 meter, B part 4 meter, C part 3 meter, D part 5 meter. So what exactly should we answer? We should say that before answering, we should like to draw a diagram, because that is the way we have studied. In fact, if we talk about the diagram, in that diagram, particularly triangle law is to be taken. So a girl moves 3 meter towards east. I can say that let's make her move towards east. Obviously, this is north, this is east, this is west, this is south. So the girl has moved some 3 meter towards east over here. What is the next part? The next part says move 4 meter towards north by taking 90-degree left turn. This means that the girl is now moving towards north. This is 4 meter towards north, and now you want a displacement. Obviously, this is the initial position. This is the final position, and anyways, you know that triangle law says that common tail and common head, you join it and you get the resultant. So that is exactly what is done next. Your resultant, I hope everybody knows this Pythagoras theorem. This would be under root of 3 square plus 4 square, that is under root 25, and that would be 5 meter. So we can easily say that D option over here does justice, and that was all the coverage for this video. I hope you thoroughly liked it. I would like to say bye bye, but before I do that, in case you loved it, please make sure you like and share it with your friends, with your colleagues, with whomsoever you feel could be benefited with this. And if you don't want to miss any further updates, do subscribe by clicking on the subscribe now button. This is me saying cheerio for now, but we'll meet back again in the next session. Thank you.